All right. So welcome everyone to Clever Wednesday. Today we have a very special guest. We have Max Stoiber of, oh, sorry, my thing went away. There it is, of ThinkMill. He's here to talk about Keystone JS and Elemental UI and React, his React framework. He will give a presentation, and then at the end he'll open it up for Q&A. So you can post your questions in the Zoom chat. That's the easiest place for him to see it. All right, so with that, I will hand it over to Max.
Hey everybody, I'm Max. Let me just share my screen really quickly so you can actually see the presentation. Give me 1 second. I hope that works. I do need to see the next slide, so I'm sort of pretending like I'm speaking at the moment. Don't worry about it. That's just the way it has to be because I don't have a second monitor at the moment. My name is Max. I work, as you said, at ThinkMill. I work as an open source developer. ThinkMill is, we are a full stack JavaScript agency. We use tons of Node.js on the back end and then lots and lots of React and React Native on the front end and on mobile. And for that purpose, we've built Keystone JS, which is our Node.js content management system, which by now I think is the Node.js content management system. And we've also built Elemental UI, which is our React.js UI library, which is still kind of experimental, but we're getting there. What I actually want to talk about is React Boilerplate, which has nothing to do with ThinkMill at the moment. If the slide would go on, that is. React Boilerplate is my own personal project. I started it about a year ago because I started working with React, and I realized at the time I was using Flux because that was about the time when React was released. And I realized after 2 or 3 side projects with it, I realized there's the same folder structure all the time. There's a tons of like boilerplate files that are always the same. They never change. And I ended up copy and pasting them all the time. And then I realized, well, I could just as well share that. So I put it online. That was February last year, I think. And then a whole lot of nothing happened. I continued to change it whenever I need it, but I didn't really use it that much because I never did that many side projects anymore. And then around December, it got posted on Hacker News for some unknown reason. Somebody just found it and thought, hey, that's cool, and posted it on Hacker News. And I woke up in the morning in December, and suddenly my little boilerplate didn't have 50 stars anymore. It had 500. And since then, and I basically at the time, it was really bad. Like it sucked. It was horrible. But for some reason, people thought it was good and used it. And so I started working on version 3, which we released 2 weeks ago, I think. And we completely changed the focus. Now, so I say we now because there's actually a team of people working on this now. It's no longer just me. There's a bunch of collaborators and contributors. There's tons of discussions going on all the time. And we realized that the way the boilerplate worked was very nice when you build a side project that's not meant to be used by anybody really. But it was absolutely horrible when you tried to build an actual product. And many people tried to do that. And the next thing we realized was that there was no boilerplate that was fit for that purpose yet. And so we began this epic 6-month-long journey to try to build the best and most scalable React boilerplate available. That has resulted in a pretty big launch. And I basically want to talk about a few things we've learned by doing that and by all the discussions that happened and all the people we talked to. So there's 4 parts to this talk. The first one is, what is scalability? Second one is state management. The third one is architecture. And the fourth one is performance. Let's start with what is scalability. Many people know scalability as a concept from the back-end side of things, right? When you build a product or a startup, what used to happen is that you needed a really good back-end engineer so that when your growth exploded like you wanted it to, your database server could be split across multiple servers because you were going to end up running out of physical space. So you needed a database to be able to be on different servers so you could sort of scale it really well to tons of users and tons of data. If you didn't do that and you ran out of physical space, right, it would be horrible and it would be really hard to change afterwards. That concept has sort of gone from the back-end side of things and moved to the front-end side of things, because we have these really complex web applications and user interfaces that need a lot of components and state. And that needs to scale as well suddenly. And it's sort of a topic that hasn't really been talked about enough, I think, especially in terms of React. And front ends can really scale in 3 different ways, right? The first one is more application, right? As our application grows and more components get added, we need to have a proper setup so that works and doesn't get painful for the developers to work on. The second way it needs to scale is more users, right? The more users use your application, it's going to be put under a totally different stress level. It needs to account for that from the very start. The third one is developers. Like an application, if it grows, it needs to scale to being worked on by potentially tens, dozens, if not hundreds of developers. And many people don't account for that. And then again, you have the same problem as on the back end. You suddenly have hundreds, if not thousands of components and hundreds of people working on it. And everybody's just sort of working on the same files, and it sort of ends up being really catastrophically hard to merge anything into the master branch. And it's a pain to handle, basically. And that's what we tried to change. We tried to give you the best setup possible to make that as easy to handle as possible. Let's start with state management, because that's a really important topic. When Facebook released React, they also released this thing called Flux, which was a unidirectional data flow library. Now, I know I'm talking to a bunch of different developers here. Not all of you might be aware of what they... Sorry, I'm getting some echo. Somebody of you has a microphone turned on with speakers, and I hear myself, which is really weird. There we go. I think it's fixed now. All right. State management. So they gave us Flux, which was a unidirectional data flow library, that I don't struggle with the word. It works kind of like this, right? You have your application, which is a tree structure of components. And somewhere down there, a component changes. And the component says, hey, I've changed. I want to change something. And so what used to happen is that component would go to its parent component and say, hey, parent component, I've changed. Right? That's two-way data binding, which we had with, all sorts of things like Angular and Backbone. And they might go to another component and say, hey, I've changed. And those then might go and say to their child component, say, hey, that component over there has changed. Something's changed. You might need to re-render. And then that will go, and it will sort of go all the way around and cross all over your application and end up being a huge mess and really hard to debug, because you'd have these really long data flows across your entire applications that didn't actually make any sense at all. And it's a pain to debug. If you've ever worked with Angular or Backbone, you know exactly what I'm talking about. And that's why they gave us Flux. A unidirectional data flow tries to change that by basically creating a cycle of updates. So again, our component at the very bottom has changed. But instead of going to its parent or to some other component and say, hey, I've changed, it now goes to this external thing called a store. A store contains just, general, like the entire state of our application, which might be things like some modal is open, or it might also be some things like some data, like those are the posts that are rendered at the moment. All sorts of stuff can go into state. And the component basically just goes to the store and says, hey, I need to change the state, that specific field, it needs to be this now. And then the store goes to the top level component of your application and tells the top level component of the application, hey, you need to re-render. And that top level component then slowly cascades down and re-renders its children, and those render their children. And we have this really nice flow of re-renders across our application, which is this really nice sort of cycle. Something changes, we go to the store, we go to the top level component, everything re-renders down the tree. Again, something changes somewhere, we go to the store, and it's just this cycle going on. It's really nice to work with and really easy to debug. Flux was nice, and the idea was really, really good. But the problem with Flux is that it uses events. So it has this concept of an event emitter, and it dispatches DOM events, which get catched up somewhere else, which works, but it's really, really hard to test. Mocking Flux actions is actually kind of hard and very painful to do. And it also feels very dirty to just dispatch global actions and hope somebody picks them up somewhere. So this really smart guy called Dan Abramov went, and last year released this thing called Redux. Redux basically takes the Flux concept of a unidirectional data flow and makes it pure. Pure in this case, meaning in the functional programming sense of pure, meaning you just have functions, they take an input, and whatever input you give them, they give you the same output. So all of your actions, everything that changes is just a pure function and really easily testable, which means you now have this unidirectional data flow thing, which is really nice to work with, combined with really easy testable, really easy testability, maybe, and just general niceness. And I highly recommend using Redux. If you're starting a new thing and if you're thinking about, should I use Redux or Flux or any other Flux frameworks like Flumux or that sort of thing, use Redux. It has the most mature ecosystem. It's a ton of people use it, and it's just really nice to work with. Let's go on to the next topic, architecture. Now, this will be Redux specific. I will use some Redux terms, but don't worry about it. If you haven't worked with Redux, you should still be able to follow. One really big thing in your React applications is splitting your components in containers and components. Containers, now this is just two words, right? You might have heard something like stateful and stateless components, or presentational components and logical components, or something like smart and dumb components. There's tons of different notations. I tend to use containers and components because it's easiest, but whatever you want. Containers are basically components that care about how things work, and components are components that care about how things look. So you end up with these two categories of components. They're both React.js components. It's a bit confusing with the container component thing, but they're both React.js components. Containers are concerned about with how things work, and components are concerned with how things look. What that gives you is, in a big application, you might have a really, really big tree structure of tons of components nested under each other in this sort of really long tree. And having top-level state is nice, but it gets kind of tedious to pass that down further and further and further, and you might lose some sort of data as you get further on. And I'm hearing some toilet flushing. What this split between containers and components gives you is that you get the sort of components that are really reusable, because they just care about how they look. They don't care about anything else. They don't care about what data they render. They just care about, I want these props displayed that way. Like, a perfect example would be a button. So you have a button that just renders, some text and has an on-click function that you pass in. And you can reuse that component across your entire application, and it's just going to work. And then somewhere in between, you have bigger components, these containers, which take care of handling data, formatting the data in a certain format so that it works for your components, or fetching data maybe, or, all sorts of stuff with data. And which means now it's really easy to debug, because if you have a styling issue, you immediately know, all right, I have to look for a component. I can go in and just change, the button if the padding isn't the right. If there's some problem with the data, all right, I don't have to touch anything that's related to styling. I can just touch my logic components, just those things, and I can fix the bug in there. And you have these sort of layers of data logic in between your presentational components, and it's really nice to work with. Second big thing is structure. When you take a look at any sort of React boilerplate, most of them still do this, they traditionally group their files by type. So they would go in and say, we have a folder for our actions, we have a folder for our containers, we have a folder for our components, we have a folder for our constants, and so on and so forth. And then, as you can see here at the example of a navbar, we've got some navbar actions and some navbar constants and a navbar reduce and a navbar container. Now, the problem with this is that as soon as you get more than a dozen components, it gets really hard to work with. Because as a developer, let's say I'm trying to add a new feature to my navigation bar. It shouldn't just toggle in and out. It should also have a secondary nav. And I need to go in and I need to find 4 files in 4 different folders, try to figure out what are the exact files are that I want, with potentially hundreds of files in that folder. And if you're touching styling, it gets even worse, because probably your styling folder has an entirely different layout than your containers folder or your components folder. And so you're trying to dig for 5 different files, and you're changing things all over the place, and it's really weird and messy and doesn't really work well, and it takes ages to do anything. So instead, why don't we group files by feature instead? So a feature is any sort of self-contained container of our application, like a navbar. That's what I had example. So we now have our containers, and inside we have a navbar folder, which contains a navbar.js file, an actions file, a constants file, and a reducer file. And I know as a developer, all right, I have to add a new feature to the navbar. So I go into the containers folder, I find the navbar folder, and I know I have all the files I need in there. I want to add a new action. I know exactly where it is. I need to add a new constant. I know exactly where it is. This gives us two really big benefits. The one is easy renaming and moving. Now, admittedly, how often do you rename things? But this is still a really nice benefit when you have to do it, because it can be really painful otherwise. Now, when I want to add a secondary navbar and I have to rename the navbar component to primary nav, all I have to do is do a global find and replace in my editor and just change it to primary nav, and that's it. And then I rename a single folder and it just works. If you try to do that with navbar action.js, navbar constants.js, navbar, you are either a regex wizard or it's not going to work. And how many people are regex wizards really? So this is already a really big benefit, because if I have to rename anything, it's just 2 minutes and it's done, which would have normally taken me a good 15 minutes, half an hour. The second big thing is you can work from a single folder, as I said. When I first heard of this layout, right, we had this huge discussion in the React boilerplate repository where people just threw in their own ideas. They just said, we did this, why don't you do this? You know, there's all sorts of stuff going on. Why don't you do that too? And I thought, so there was a question. I'm probably just going to answer it because it fits contextually. Let me just finish what I was saying. And when I first heard this layer, I went, that sounds really weird. Like, I've been doing this actions folder, constants folder, reduces folder thing for a very long time. It works. Why should I change it? And then I tried it out on a project. And within 15 minutes, I was 100% convinced that that was the way we're going to do it. It's just so much nicer to work with as a developer. It's incredible. Now, the question that just got asked in the chat is, would you have an objection against using a DUG instead of single files? Now, for those of you who don't know, DUGs are a concept publicized by Erik Rasmussen, which is that you only have a DUGs file which contains all relevant actions, the reduces and constants with a specific feature. I don't like it, for the simple reason that it's really weird to work with, because you need to have very specific exports for it to work. So any developer that comes into your code base will have to follow that very specific structure of exports and imports. And it also couples actions to reducers, which in Redux, actions can go to any reducer. Like, you can dispatch you can have a toggle nav action, and any reducer can pick it up, not just a navbar reducer. By putting them all into one file, it sort of seems like you have to use those actions in that file, in that specific reducer, even though you could just as well use it somewhere else. And then junior devs might be, or even like advanced devs, I did that for a very long time. I just dispatched 2 actions, and I added 2 actions where I would have only needed 1 and should have just, replied to the same action in a different reducer, which is why I personally don't like and use DUGs. But if it works for you, it's a nice file saver. So you don't have 3 files in your folder anymore. You only have 1. And to go on with the talk, the last big benefit of this is reusable components. Because since we now have everything contained, we can just put all of that JavaScript code onto NPM and can just have it in a private NPM thing, and can NPM install it and can just use it. And if I need to change something, I can change it in a different repository, update it, publish a new version, and it's going to be automatically in all of my applications after a while, as soon as they basically redeploy and reinstall the new modules. That wasn't possible before. I mean, try sharing 5 different files out of 5 different folders, and you're going to have a very bad time. Now, I've sort of touched upon this. I haven't talked about it at all. Styling is a big issue here. That's what I thought too. When I first tried this, I went, this is really nice. But now I still have that separate folder for my styling, and it's sort of not very nice, and I'm not sure I like it. It's sort of like it tries to follow the same structure maybe, and it didn't quite work. There's 2 big problems with styling in a component-based system, right? The first one is naming. You can have naming clashes. Because CSS works in this global cascading thing setup, when you have 2 CSS files, one which contains a .header class and a .title, and one which contains the footer class and a .title, and they have different properties, you're going to get a conflict. And suddenly your title has a background color of yellow, but also a border color of blue, and you're left scrambling trying to figure out why exactly did that just happen? And it gets even worse when there's logic involved, because then some classes might only be applied if, certain logical things are true, and then those bugs only appear in the very rare circumstances. And if they appear, they're really weird and they don't make any sense, and it's really hard to track down. The first good idea to solve this was naming conventions. So you'd have naming conventions like BEM or SMAC CSS or something like that, where you group your names to a specific component. So instead of doing .header and .title, you do .header _ title in BEM, for example. And that way you could avoid naming clashes. That works really nicely. It works really nicely for small to medium-sized applications. But when you're building a big application with hundreds of developers, and you're potentially using some sort of preprocessor and you're nesting your CSS classes, you suddenly have no guarantee whatsoever that that class doesn't exist before. And while I'm sure all of you do check that you don't have a naming clash before you add a new name, there is developers out there that just don't care about their code. That's just a fact that has to be accepted. I personally really care about my code quality, but many people just don't. Many people just do it as a job, which is absolutely fine. And at that point, you have a developer that adds a new name, but doesn't really care to check if that name already exists or anything, and you're going to have naming clashes again. No matter how good you try to do BEM and follow everything, and it's still going to have naming clashes. It's just going to happen, and it's really weird and hard to track down, and it's a horrible bug. So some very smart people came together and tried to solve this with a thing called CSS modules. CSS modules are used like this. I'm going to show you how to use it first, because then the next explanation is going to make a lot more sense. We're importing a CSS file and then setting the CSS file as a class name. That might look a bit weird at first, but this is Webpack specific stuff. So if you're not using Webpack, I think you can use pre-post CSS, and I don't know if it's implemented for Browserify yet, but this is Webpack specific. So we set a class name of styles.footer, and then that .footer class we can simply set in our CSS file as normal. We can just use normal CSS, and it's going to apply that class to our component. But what it's also going to do is it's completely uniqueify our class name. So it's not only going to say, hey, okay, that specific part of our React component has a class of footer. It's also going to say, hey, we're going to namespace it to our application, and we're going to post-append a hash of the contents of the CSS class. Which means suddenly you will never, ever have naming clashes again. Because if you have a naming clash, if you have two classes with the same name, they're either not going to have the same hash because they don't have the same content, or they're going to have the same hash, in which case they have the same content anyway, so it's no problem. It doesn't matter. So you no longer have any naming clashes, which is really nice. Avoiding that bug entirely is really, really nice, and it's also really nice to work with. There's a second problem with CSS, though, which is inheritance. Right? In CSS, certain properties, about a dozen of them, inherit across DOM nodes. So something like line height, when you have a .header class that has a line height of 1.5 em, that's going to propagate down to any further down DOM node. The thing is, that's perfectly fine, and it has its use cases. But when you have a big application, something like this happens very fast, where you have a header, which is a title, and it sort of has a line height of 1.5 em, and the title is a completely separate component. And then you're trying to reuse that component in the footer, and suddenly it doesn't look the way it should at all. For the simple reason that it's now inherited the wrong line height from the footer, which is in here 1 am. That's just a conflict. And now your reusable components aren't really reusable anymore. In CSS, there's this concept of global resets, right? You can wrap a reset around your application to normalize styles across browsers and to sort of have a solid foundation and consistent foundation, especially across different browsers to build upon, to build your styling upon. What if we could do the same thing, but locally? What if we could have a reset around every single of our components, saying, hey, there is certain properties that can inherit, but I don't actually care about inheriting them. So I'm just going to set them to default, and that way I'm not going to be affected by anything that happens outside of my component. Now, obviously, I wouldn't be saying this if that didn't exist, right? There is a preprocessor called PostCSS, which has a plugin called PostCSS AutoReset, which does exactly that. It adds borders between components, so no inheritance can happen anymore. So if we have 3 different components, a header, a title, and an anchor, the title and the anchor, if not specified otherwise, will have their line height reset to default, which means they no longer inherit the line height from the header or from the footer, which means we just avoid that bug entirely, right? So now, no matter where we put our components, now I lost my word, where we put our components related to styling, right, in like a button, it's just going to look the exact same. It doesn't matter if you put it in the header, in the footer, in the body, anywhere, it's just going to look the exact same. There's no inheritance anymore, which is incredibly nice when working in a component-based system. It makes everything so much easier to reason about because you suddenly no longer have to check for every single use case across your entire application, checking, hey, does that still work? Does that still work? Does it work over there? Does it work down there? Does it work on this side, on that side? You just don't have to do it because it's going to look the exact same everywhere. That's nice and all, but that has a much bigger benefit as well, because now we can also co-locate our styles file with our containers, which means now we really have every single file associated with a certain feature in the same folder. Since we're just importing that styles file in our component, right? It's related only to that component anyway. So suddenly we really truly have achieved complete component isolation, right? We could just take that navbar component, again, put it on NPM, and this time we wouldn't even have to care about styling. We just NPM install it and use it, and it's just going to work. That is incredibly, incredibly nice to work with. Not only do we discourage certain bugs or just completely get rid of them, you also are much clearer to work on it as a developer and as a team. When the discussion first came up to make actions and constants and reducers co-located with components, some people raised a valid concern, which is how do we do data fetching? It's quite common in the Redux world at the moment to use something like Redux Slank, which is a plugin or an extension for Redux, which allows you to return functions from actions and do asynchronous stuff in there, and then allows you to dispatch new action from there, which means you can use it for data fetching. And many people use that, and it works perfectly fine. But then sometimes you end up with these really long actions that are really hard to test because you have to mock a bunch of different functions and you have to sort of double call them, and it's really weird. And they're global, right? These actions are just global. The data fetching mostly isn't related to a certain component. It's just, your app needs a certain amount of data, needs some sort of data. So where do you put them in this layout? Where do you put your data fetching stuff in this layout? So let me just drink because my mouth is getting a bit dry. When you have two components, and this is slightly related to data fetching, which is why I'm doing it here. Let's imagine a clock and a timer component, right? And the clock has a start button, and when you click that, the timer should start counting its time. And then the timer has a stop button, and when you click that stop button, it should just stop. Now, commonly you would do something like this, where you would dispatch and start timer action from on-start click from the clock, and you would dispatch a show time action from the on-stop click prop in the timer. And that works perfectly fine. But then you run into a problem, because if you want to reuse a component that uses these two components like that, it's just not going to work. These two components are now no longer reusable. They're really tightly coupled to this implementation where you have a timer, they just have a clock, and you have to have both, or otherwise it doesn't work. There's this thing called Redux Saga, which solves this in a very nice way. Redux Saga sort of acts like the motor between our really decoupled components and can also be used for data fetching, which is why it's really important here. So instead of doing the thing we did before, what we do now is we simply dispatch an action saying start clicked, and then we simply dispatch another action saying stop clicked. Instead of specific actions pertaining to a clock and a timer, we can just say, the clock just says, hey, the start button in this clock was clicked. Application, do something with this. And the timer can do the same thing, right? Hey, application, the stop button was clicked. Do something with this. I don't really care what you do, just do something with it. It's happened. And then Redux Saga can go in, and it can pick those actions up. So this is what a Saga looks like. This is an ES7 generator. If you're not familiar with them, I highly encourage you to read up on them. If you're wondering about the while true statement, the fact is that when you use yield in a generator, it just pauses execution until the thing on the right of the yield statement happens. In this case, we wait for an action with a type of start button clicked to be dispatched. Only when that happens, the generator goes on to the next thing that's to the next code. So while it is in an endless loop, it doesn't actually do anything most of the time, except when that specific action is dispatched. And when we dispatch an action with the type of start button click, what we do is we dispatch another action saying, hey, start the timer. And this way, the clock isn't the way there's a timer on the page. The timer isn't the way that there's a clock on the page. They're both completely decoupled, and our Redux Saga acts as the motor, right? It keeps them together. Because then we just wait for a stop button clicked action. When that happens, we stop the timer and we show the time on the clock. And the thing is, this is a highly asynchronous flow, right? This is normally you would do this with some sort of callback where you'd wait for the start button click action to come in, and then you call a callback, and then you dispatch a new action or something like that. And it's really weird. What Redux Saga does is it uses the ES7 generators to give you this very asynchronous flow, but make it look very synchronous. And this is really, really easily testable as well. So not only is it extremely readable, because you can just go in and say, hey, okay, we're waiting for the start button, click the action to come in, and when that happens, we're going to dispatch a new action saying start timer. And so it's like a novel you read. You no longer have any weird sort of callbacks. No, like we all know that sort of code where you have callbacks instead of callbacks instead of callbacks instead of callbacks. And suddenly you're trying to scroll your editor to the right to get to the innermost callback, and it's a pain in the ass. It's really bad. So this is just so much nicer to look at and so much nicer to program as well, because you're no longer trying to count braces or anything. You're just, waiting for a thing to happen and then doing another thing based on that. This gives us really, really decoupled components, right? Our clock doesn't have to be aware of our timer. Our timer doesn't have to be aware of our clock. We can share those, all the styling, all the actions, all the constants, all the reducers associated with those components are in the same folder. So we can just share them up to NPM, to some sort of package manager. We can install them across all of our different applications and just reuse them perfectly fine and tie them all together with Redux Saga. All right, short summary of this really long section. First thing we talked about is containers and components. Split your components into containers and components. Second one is group your files by feature instead of by type. The third one is isolate the styling with CSS modules and some sort of auto reset. If you're using inline styles, GSS has another plugin which is also called GSS auto reset, I think, which does the exact same thing. So no matter what you're using, this is definitely possible. And then the fourth one is a bit weird, use Redux Saga, but believe me, when you try it, it's amazing. It's absolutely amazing. And with these four things together, you really get into a territory where it's just, you go into a code base and you're like, oh my God, this is so nice to work with. What is happening here? I don't have to search for any files. There's tons of bugs that are just taken care of by default. Everything just works exactly the way I want. I can use my components from somewhere else. It just works. It's beautiful. When I first tried this, when I first heard of this, I thought it's the worst idea ever. When I tried it, I was like, holy cow. This is huge. This is exactly the way I want to be building my applications, which is why we built it into React Boilerplate. So React Boilerplate now uses all of those things that you just heard and has them included by default. All right, the fourth big section of this talk, and the fourth big section you have to be aware of when you're building a large application, is performance. Performance, there's two different ways performance can go, right? There's two different types of performance. One of them is loading performance. How do you manage a big application so not all of the stuff gets downloaded at the same time? And the second one is obviously application performance. How fast is my application? How performant is it even when I'm doing really complex tasks or data stuff? So for loading performance, use Webpack. I know very specific tool requirements, but use Webpack, and because it has this thing called code splitting. Now, I don't have any code examples here because code splitting is about to change really heavily with the second version of Webpack, and it's really sort of in a fluxy state. But what code splitting essentially does is you can tell a Webpack, all right, here's sort of a separate entity in my code. This code is not concerned with anything else, right? Like, for example, a good example in a React application would be a route. Basically every big React application will have routes, right? Some sort of sub-URLs. And those routes might have some components. But those components might be very specific to that route. For example, when you have an about page, you don't want to be sending down the about page content when the users load something entirely different, right? The web, by default, if we don't use any sort of client-side frameworks, works exactly like that. When you open a website that's just static HTML files, what it does is it downloads exactly the content you want, not more and not less. with the emergence of client-side JavaScript frameworks, it's sort of become accepted to just bundle everything you have into one massive file and just shove that down a user's line, right? And you end up with these really long loading times, which are absolutely not necessary, because what you're doing is pushing down hundreds of routes, of which the user might only be visiting one, which doesn't make any sense at all. So with code splitting, we can do the exact same thing that the web does by default, which is only send down the content as a user wants and some shared stuff like, shared styling and shared logic. It's all, Webpack takes care of all of that for you. You don't have to say, okay, this is shared, this isn't. You just say, okay, this is a separate route. This has entirely separate content, entirely separate, some entirely separate logic, and only send that down when we actually go to that specific route. Again, I'd love to show some code examples here, but this is really in flux. So take a look at the React boilerplate repo, which is under github.com/mxstpr/React boilerplate. Or maybe we can do it. Since I'm sharing my screen later on. But this is changing really heavily, but definitely use code splitting. There's just no way around not using this when you're building a big applications. The performance impact is massive. Right, so that's loading performance. What about application performance? Again, we have this now slightly larger component tree of our application. And again, something somewhere down there changes. And that then goes to the store, which goes to the top level component and says, hey, top level component, you have to re-render. And by default, what React does is, and that's what React is really good at, is doing differs and rendering stuff, right? So it's really quick at rendering stuff. So we just go and say, hey, okay, the top level component goes, hey, okay, I've re-rendered. And then all of them, the childs go, hey, I've re-rendered, and then so on and so forth. And, so you're re-rendering the top level, the children, again, the children, and so on and so forth, down the entire tree. And you've re-rendered the entire application, and everything works perfectly if my computer didn't hang. The thing is, really, what we want to be rendering is not the entire application just because something somewhere very far down has changed, right? We might only want to re-render this thing because it might be some sort of input. And just because the input value has changed, we don't really want to re-render our entire application, right? That doesn't make much sense. So React gives us this really nice lifecycle method called should_component_update. What should_component_update allows you to do is bail out of renders. So if your component specifies a should_component_update function and returns false from it, the component is never going to re-render. If you return true from it, it's always going to re-render. But the thing is, you get the next properties of your component in the should_component_update function. So essentially what you can do is compare them to the current properties and check if anything has changed. In our very basic example, we want to bail out here, here, and here, right? The thing is, we really want to bail out as early as possible. Right? We want to bail out as high up in the tree as possible because the further down we get, the more stuff is re-rendered. So I think the most important bailout in this case is the one on the top right, where you have, which is the highest up component we can bail out of. Nothing under there will even know anything has happened. It doesn't care because the top level component knows, hey, my children don't care about this. So, leave me alone. I'm not going to re-render. What does this actually look like, right? So you have this should_component_update function, and basically, what you should be able to do is return next props does not equal this props. And then, if they have changed, they have changed. And if not, they haven't. And then it just works, and that's it, Except in JavaScript, it's sadly not that easy. Because in JavaScript, when you have two objects and you try to compare them, they're not the same, even though the contents of the object are the same. And the thing is, what you could do is loop through all of the object's properties and compare all the values against each other. But deeply comparing objects, it's really expensive because you have to go through every single property and value, which might potentially be nested, and there might be more objects or more arrays in there or more, even more stuff in there. And you're trying to compare them all the way down. And since we want to bail out as early as possible, we basically want to compare really big state trees potentially, right? Because we want to bail out really high up. That might still have a ton of data or state associated with it. And we want to compare that with another really big state tree. And suddenly you end up just cycling through the state trees endlessly, trying to compare them. And it takes ages and it's really slow and doesn't really speed up your application. Instead, there's this library called Immutable.js. Now, Immutable.js gives you immutable data structures in JavaScript. If you do something like this, where you wrap an object in this from.js function, you can now no longer go state.username equals something else. Immutable.js will throw an error when you try to do that. Now, that's it's nice if you like functional programming. It makes your life a bit easier. It forces everybody to do functional programming, which might be nice, and it sort of gets rid of a few bugs. But it's not really important. It's a huge library. Is that really worth it? But then in Immutable.js, when you have two objects that are wrapped in this from.js thing, which Immutable.js makes a map out of or some sort of records out of, what we can now do is we can do .equals to compare them. And what Immutable.js does is when you first create the object, since this object can never be changed, it can generate the hash of the contents. And then when you have two immutable objects, right, they both have some sort of hash associated with them somewhere in the property deep down within the object. And if you do .equals, we're basically comparing two strings against each other. Instead of looping over our entire objects and trying to compare every single property and value, we're now suddenly only comparing two strings and deeply comparing our entire state tree, which allows us to really, really cheaply compare big states really high up in our tree. So now what we'll end up doing, as soon as Keynote likes to go on, is we can do the exact same thing we wanted to do beforehand, which is use should component update to bail out really early, right? So when we have a re-render, we're re-rendering there, and then we bail out, and the only thing that's now re-rendered is the exact part we want to re-render, which is the one on the left. Right. Short summary. What is scalability? Scalability is the ability of a system to grow to handle more amount of something. That something could either be handle more users, handle more developers, or handle more application. State management, use a unidirectional data flow library. It makes big applications a lot easier to reason about. Specifically use Redux for two reasons. One, it's pure and really accessible and really nice to work with. And the second one is you get Redux Saga, which makes this whole thing even nicer. The third one, again, was the architecture one, where we've had split your components into containers and components, structure your files by type. Now I'm saying it right. Structure your files by feature, not by type. Isolate your styling with CSS modules with unique class names and local resets around your components. And use Redux Saga, which you only get with Redux. So use Redux. And then the fourth is performance. For loading performance, use Webpack and code splitting. And for application performance, use Immutable.js to really early on bail out of re-renders in your component tree. Thanks for listening. Ignore the tweet comments and questions and feedback to me. You can just write in the chat and I'll try to answer your questions. Thanks for listening.
All right, so I think we're going to open it up to a Q&A session now. Does anybody have any questions for Max?
Yeah, I do. I've done a lot of profiling with React and Immutable on really large applications, and it does tend to make the execution time shorter than the approaches we used before. But because one, Immutable, to make it so if you instantiated those immutable objects, it'd point to the same thing, it uses shared state, and it tends to hold on to that, especially in a single page application. Also, with React itself, how it manages the virtual DOM, especially when you have a big tree, that tends to hog memory too. So I'm interested if you've come up with any novel approaches for monitoring that.
I wish I could tell you I have, but I absolutely haven't. I've worked on an application which has run into this problem, and it's a pain to work with because you're basically trading application performance for memory, more or less, in a certain way, right? And the thing is, Immutable.js is a huge memory hog, as you wrote in the chat. I have no idea how to solve that. If your application gets to that scale, you're probably going to have to write some sort of custom solution, which we ended up doing. But I wish I could tell you any more. I have no idea. I'm actually really interested in how Facebook handles this because I think it's probably the biggest React app ever. And I know they make Immutable.js. I don't know if they actually use it in their main application, but if they do, I'd be really interested in how they solve this because I basically have no idea. I'm sorry.
Okay. I had another question as well. as well. I'll post it into the chat. It's I saw in your example that you were showing using dispatch directly. And I'm wondering if you do that only in containers or if you're doing that also in components, because I see part of the benefit of using something like Redux is not dispatching events from anywhere, because you use Backbone or a custom solution. That's where things tended to get hairy, is where you're emitting notifications from anywhere.
Yes. No, I solely do that in my containers, which is another nice benefit of using containers. Because the containers, I use React Redux. I think most people who use Redux and React do. It gives you this really nice connect function, and you can simply pass in, you can basically take it from the context, right? And then, as I said, I tend to just have specific handlers of my components, and then dispatch from the containers, which makes, again, a really good point. I should probably say that in the talk if I ever do it again. But yeah, I tend to only dispatch in my containers.
Makes sense.
There was a question, I'll just read it. With the React method of importing styles, what's the proper way to handle global theming across components? That is such a good question. I'm loving this Q&A already. Global theming is a fucking hard problem. Sorry for the swear words. It's a really hard problem. There has been so much discussion around how to properly do global theming. I think currently the best way is to use inline styles, because what inline styles give you, if you need global theming, is they allow you to use JavaScript variables in your styles, basically, which allows you to compute variables based on your state and change the styling on the fly, which is really nice. But then you lose the benefit of being able to use preprocessors like PostCSS and automatically adding prefixes and all that sort of stuff, which is why I'm personally not a big fan of inline styles. So there is a way with Webpack to inject JavaScript variables into your CSS file. I don't specifically know how it works at the moment because I haven't actually used it. I know it exists. I can look it up for you later and try to find it. Oh, actually, let me do that now. Because if my computer would like to not show a black screen, that is. We use that in the React boilerplate side, I think. So if we go to React boilerplate site. Now, the good thing with making an open source project is you don't have to take care of all the work. So the site was entirely not made by me. I didn't do anything. So I can't tell you the specific example, but as soon as the site loads, I will tell you. But basically, either use inline styles or somehow inject variables into your CSS with Webpack, which as soon as this is loaded, I can show you. I think we can go to the next question meanwhile. There we go. I foolishly upgraded to macOS Sierra yesterday, and now my MacBook Pro from late 2013 has a huge CPU and memory problem. Don't update to macOS Sierra yet if you're on Mac. Don't do it. Just don't do it. It was the worst idea I've ever had. But I mean, it's worked out today, so that's good. So in our Webpack configuration, let me try to find where we actually do this. No, not here. Do we do it differently for development and production? We actually kind of do. So sorry, it's a post-CSS feature, it's not a Webpack feature. So CSS Next allows you to do custom properties and pass in an object as variables. And it injects those as, the new CSS spec for custom properties. It basically injects them. So if you look at this CSS config file, which is an app/cssconfig.css, JS, what I'm talking about, you'll see it's basically just an object that has CSS in it. It's a bit weird because you have to take care of adding, different types of quotation marks inside and stuff, but it works and it has the same benefits as inline styles without losing the benefits of a preprocessor, which is really nice. Does that answer the question? I hope it does. Basically, use inline styles or use CSS Next, I guess. So there was another question. Given that you're using transpilation and plenty of async code, do you have issues digging into exceptions? Both transpiling and promise-like code tend to make isolating the source of errors difficult. Yes. Redux Saga, because they use generators and because generators aren't supported anywhere and you can't really transpile them, you have to include a generator polyfill with Babel regenerator. And it works. I mean, it works perfectly fine. But it does tend to give you really weird stack traces. And Redux Saga actually has an issue, which I probably can't find now, so I won't try to. But they have an issue where they're trying to add better error boundaries. So they're working on improving the stack traces, basically. It's a bit hard at the moment sometimes when you get errors in there, but they're working on it. They're aware of it and they're working on it. Any other questions? I have a question about the generator function in the example you mentioned, which it is waiting for a stop button action. Is it blocking the thread of JS? I mean, is it asynchronous too, or is it blocking? No, it's completely asynchronous. So ES7 generators are a really nice feature that allow you to write asynchronous code in a very synchronously looking manner. So based on the question, let me see if I can actually open Atom. If I crash now, don't worry, I'll be back. That's because I'm using macOS Sierra, but it should work, hopefully. The thing is, they give you this really synchronously looking code, but it's actually completely asynchronous. So with the yield keyword, we just wait for the thing to happen. It's kind of like a callback, except it doesn't look like a callback, which is really nice. So no, it's not blocking. It's asynchronous. Since Atom isn't starting, I can't actually show you a code example. Another question, maybe? Yes, no. So the question was, I wonder if a Babel or an AST-enabled Webpack plugin could get rid of the while true boilerplate. In fact, the Saga example I showed you is a really basic one. Redux Saga has a really nice utility function called, let me show you the PR. It has a really nice utility function called race, which allows you to spawn new Redux Sagas, new asynchronous flows based on a certain condition, and then stop them when another condition becomes true. So you can really easily get rid of the whole while true thing. Let me show you, because somebody just today submitted a PR fixing that. Thanks to Justin Greenberg for showing me this, because I did not know that worked. So what we can now do is, I need to move the chat out of the way because I can't actually see anything. So what you see down here somewhere, we had a while true, and we use this watcher to start and stop based on whatever happens. So what we do here is we wait for the load repos action, and then we stop again when the location change action comes in, because we want to stop the Saga when we're changing to new route. And then if the watcher does stop, we just break. Now this is actually much now. Sorry, struggling with Zoom at the moment. Let me see if I can move that out of the way. What we do now is instead we have this get repos watcher function, which still has a while loop, but it actually waits for the first load repos thing when newly open, and then just calls the other Saga, which is this one, get repos, and which then actually gets the repos. And that way you avoid the while true boilerplate. And because you have this watcher down here, so this is what is actually started by the Saga middleware. We have this watcher, and then we fork the get repos watcher Saga, which is this here, which just waits for the load. Just every time the load repos action comes in, it just gets all the repos, and then we wait until the location change action comes in, and then cancel the watcher. And it's a lot nicer than the whole while true things. The next question was, are there any plans to add hot module reloading to this boilerplate? Hot module reloading is in this boilerplate. If you're not seeing hot module reloading with the boilerplate, it's probably because you're using stateless functions, which don't support hot module reloading yet. If you change your components to ES6 classes and or Reactor create class notation, you will see hot reloading. It's incredibly fast because we just had a great PR by a guy called Söderpop who implemented the Webpack DLL plugin. I'm not going to show that because it's really complex, but it made hot module reloading a ton faster. So yeah, there is hot module reloading in the boilerplate. I'll have to go pretty much on time. So let's do one more question maybe, or two, depending on. What tools do you use to measure performance? I mostly just use the Chrome Dev tools and PageSpeed Insights and Web Page Test. I think that's pretty standard. The Chrome Dev tools are really nice. They have a bunch of really nice profiling stuff that makes it really easy to test your applications and measure the performance of them. Let's do one last question before I go, if there is another one. The question was, have you experimented with using Saga, with Yo-Yo, or any other virtual DOM using libraries? No, I haven't at all, because I'm a big React fan. I haven't had a chance yet, but there is a great gist by Sebastian Lober, which I will post into chat, where he explains how to use Redux Saga completely outside of the entire Redux React ecosystem, which is really nice and a really good reference. I hope that's the right choice, but I think it is. Another question, maybe? Sure, no worries. You're welcome. I hope everybody enjoyed the talk.
And this was really great, Max. We really appreciate it. And I'm sure
Awesome.
Moving forward, they'll get lots of questions as our developers start implementing some of this stuff.
Awesome. Yeah, just contact me on Twitter and ask me anything. I respond. If I'm awake, I respond as fast as I can, basically.
And not in the middle of the night.
No, I won't respond in the middle of the night.
All right. Well, thank you so much. I know you got to get running.
Yeah.
Thanks everybody for attending.
Yeah, thanks for coming. Hope you enjoyed it. Have a great one.
You too.
Bye.